Hello, and welcome everybody to today's class. And today we have a new day and a new class for XR Bootcamp. As we all know, from last few days we have been looking into ARFoundation, and I believe it has been 3 to 4 days now that we have been looking into ARFoundation. So today is the very last day of ARFoundation, and the sole reason that we were looking so deeply and greatly in ARFoundation was because ARFoundation is a pretty powerful SDK, which any AR or VR or any mixed reality developer or XR developer needs to know, right? Basically, it's more or less for AR itself, that hence the name ARFoundation. But yes, it opens up a lot of possibilities. Then you can go to Mars, Unity Mars, and then to XR Interaction Toolkit, which again is used into Unity for VR and stuff, right? So ARFoundation is a key role player in the development of AR with the help of Unity, and that is why we have been looking pretty closely with in it, right? So let's start today's video, and let me start off. Okay, so let me go to Unity, increase my video size, and yes, that seems right. Okay, so now what I want to do in this session was I wanted to, although we have looked into different and multiple features of ARFoundation, for example, plane detection, anchors, raycasting, air raycasting, point clouds, and whatnot, right? But in this very video, I would like to give you a glimpse of a few more features which might not be that important, but they are really handy when you want to create a realistic looking AR experience, right? So let me just go back to assets, go to scenes. This is our very own, AR foundation sample in which we have made our own projects as well. So as of now, we'll be going through a few more scenes, which are the sample scenes that are provided to us by Unity itself, right? And here, the first and foremost scene that I would love to go through will be this very basic scene tracking. Okay, and this is a scene that is open here, and let me position my video right here. And here again, as we did in Vuforia, if you remember, we created a image based experience in Vuforia, right? Similarly, we can do that in ARFoundation as well, and for that there is this example, basic image tracking. Okay, so again, as we all know, that ARFoundation gives us multiple tools, and if you want to use those features, what we have to do is we simply have to use the right components, right? So let's go to AR session origin and see what are the components that have been added here. Let's so the approach that we'll be taking here would be, we'll be going through the scene, okay, trying to understand the scene, and then we'll play this very scene into build it and load it in our phones, and then we will look at this video recording that I have done on my Android phone, right? And then we'll try to understand what's happening and how things really work, right? This way we will be able to go through multiple examples, multiple different scenes in less time, and that is what we want, because we want to end the tutorials for ARFoundation today in this very video, so that we can move on to our next things. Okay, I know ARFoundation was really exciting, and you guys will be still exploring ARFoundation and will get to know about multiple more features that will now and then will be added again and again, because AR core is coming up with new features. AR Kit is also coming up with new features. For example, recently AR Core just released its Geospatial Anchors API, right? So we know anchors, so understanding geospatial anchors won't be a big task. Basically, geospatial anchors in a nutshell is the ability to create anchors with the help of it's the ability to create anchors in real world with the help of latitude, longitude, and very exact altitude, right? So that is the fun with geo anchors, right? So we'll be looking through that. Okay, maybe you would be looking through those, and multiple of such features will be added in ARFoundation now and then. Okay, so today we will be trying to look at a few more demos that we haven't covered yet, but which maybe in turn in any of the AR experience that you might be building in the near future will definitely be helpful, right? So we don't want to miss out on any AR features that the ARFoundation provides. So here, if we see on the AR session origin, we have this AR session origin component, which is always there, which manages the session and stuff, right? Then we see a few more sessions. So here we don't see, AR tracked, AR plane manager, AR recasting manager, or for, as a matter of fact, we don't even see AR point cloud manager, because we are not concerned about any one of them. Why? Because in this experience, the sole aim is to detect a very image, detect the very image that the user has already preset. Okay. And for that, we have this AR tracked image manager, right? And it gives you a few, options, right? So first is this reference image library. Okay. This you can see. So this is a reference type image library that has been created here, and you can add multiple images into it. Okay. So these are the images that have been added. Okay. Again, going back, then here it says max number of moving images. That means at a very point, how many images can be tracked at a given frame. So 4 images can be tracked. This is the image info track prefab. Then we have image tracked image info manager. So this takes care of the tracking of the image and stuff. And then here we have dynamic library. Here we go, and here we have set, okay, this is the image and we need to show this very image. Okay. And we have set the width. If you remember, this width feature or this width property was also available in Vuforia itself, right? So these, all these SDKs, AR SDKs, they work in a similar fashion, right? On the core of them, they basically are using the same or similar, at least, if not same, for sure, similar computer vision algorithms that detect those images or detect those planes and stuff. Okay. And then in AR session, we don't have anything. We have the AR session and AR input manager. And then this is the event system and the canvas, right? So basically they have used these 2 to 3 components, which is AR tracked image manager and this info, right? And now let us take a look at how it looks like, when it runs on your smartphone. So this is a demo, and here what we'll see is, as soon as we show it the image, so maybe if the image is one and our app is built to identify this image, then we would be able to identify that. But I figured out that this very experience initially is built to identify this QR code. So as soon as I go near it, if you see closely, on one, it won't do anything. It won't show me anything. It won't do anything, right? But as soon as I go to the QR code, as of now, also this has not been detected. Why? Because this QR code is on my Mac screen, right? This is an image, and it is not a, it's not printed on paper and whatnot. So that is why you can see this glow, because this is the screen brightness, right? That is why it is having some issues, identifying it. But as soon as I go near it, this snaps onto it, and the virtual object or image or whatever we want to place, it comes and play. It is like, it is just directly placed on the image. Okay. And if you can see here is some text as well. Okay. So this is the information about the text and stuff, right? So that's not really important, but if you need it in some way or the other, that has been given here, and you can explore this, for example, to see how you can do this, right? And as soon as we go near it, we see it, right? So again, as I remove the image, like the image is gone, like the 3D image or the 3D model is gone. I don't see it anymore. But as soon as I come back to the marker, I see it again. Okay. Again, here you would see, although the image is one, but still this is being shown. And this is so because of something known as, again, that the extended tracking feature that Vuforia had. Similarly, this is the one, right? So this is trying to capture it and place it again, but that is not being placed. So okay, but as soon as I show it again, QR code, again it will snap right there, exactly right there. Okay. When we were saying it, when we were showing it image one, it was not moving and stuff, right? Although the best or the adequate behavior or the right behavior would be that this QR code should be gone, right? But I believe they're using extended tracking, something or the other, like extended tracking. That is why the QR code stays there for some time, in order to see if that can actually get the required image, right? But as soon as we show it the image that we need, it quickly snaps onto its right position. Okay. So this was a very simple example of basic image tracking, and I strongly, highly recommend you to go through it, because this kind of experiences can be, quite handy when you want to create something pretty easy. At the same time, you want to create it quickly, but you want to create an impact. For example, what do you guys think that what could be a good example of using such, image based AR? So a good example of this would be teaching kids. Why? Because if you know, whenever there are books for kids, for example, if they're learning pretty basics or things, there are multiple images, right? Kids love to read storybooks. So there has been great examples, and a lot of companies have made a fortune out of it by using image-based AR for children's storybook, right? So basically, whenever the children read the storybook, he or she can scan the images and they would actually come to life. Okay. And whatever story that has been written, that can be, that plays in the 3D with the cartoon characters of the story itself, with the narration, with the sound narrating the story. So that has been a pretty popular strategy, and a lot of companies, I believe, outside India. One of the companies, I don't think if I can name the company, but there are some German companies which are doing this, and they have been really successful, right? So this was a brief about our image tracking scene. Okay, let's move on to our very own next scene. So if we see, we have face tracking. Yes, that is one of the things. Human tracking. So I don't believe that is available in Android. Okay, this brings us to another point, that all the examples, all the example scenes given in ARFoundation might not work in Android. Why? Because some of these features are not even available on Androids, right? And ARKit has already launched it. So now ARFoundation is built for both Android as well as ARKit, right? Android and iOS. So they have to keep up to the mark. That is why they add the examples of features that are already present in iOS, that is ARKit, but not in Android, that is ARCo. So such is an example of human tracking. Okay. So this very example might not run on your Android phones. Okay. So if we go here and we open the human pose tracking 3D, and here, if you go again, if you see AR session origin, here you would see this AR human body manager. And here you can put your own very human, humanoid kind of character, maybe, an RPG character or any character, humanoid character, right? And then actually, what happens in this is using ARKit has a capability to actually scan whatever, whoever human is there, and actually get the information of joints like the shoulders, the knee, the elbow, the hands and whatnot. And it can actually move the hands or, the shoulders of the 3D objects as it is, as the human in the frame is moving, right? So that is one of the things, but this cannot be done in AR core as of now. So see, this is a 3D model that they have placed, right? And if you run this, for example, on your iOS device capable of processing this human body tracking, then you would see, whoever, if there is a human in the frame, however the human is trying to move, this character will automatically be copying the moves of the human. Okay, so I cannot show you the screen recording of this because I do not have a iPhone or an iOS device handy to me right now. Okay, and what else can we see? So then what else we have? We have depth. Okay, so depth will also, if you go into depth is also a good feature. Basically, this is used for occlusion. So some of the devices have depth functionalities as well. Some of the Android ones as well as the iOS devices. Okay, so now if you are available, my bad, if you are, known about the depth in the scene, then you can accurately place the virtual characters or objects using occlusion, right? For example, if I know, if my device is capable of knowing the depth, right? And if there is a this chair is there, right? And if I'm seeing this view from here, if I place my virtual object here in front of the chair, it will be visible to me. But if I place this behind the chair, it won't be visible to me. And that is how real objects work as well. So that is known as occlusion. Okay, so I try to build this although I know that I didn't have the AR capability, like the depth capabilities on my Android, but I still gave it a try. And yes, it said the functionality is not supported on this device. And but what this example does is it shoots projectiles. If you click on the screen, it will shoot a projectile. And on the depth enabled devices, these projectiles would actually hit this table, okay, and fall here and there. And if they go beneath this table, we won't be able to see them. Okay, so this is what the depth is capable of. Okay, so for depth, let's check out what they're using. How can we do depth, right? So they're saying this is a depth availability checker. Okay, and then in, I guess, in AR camera, they have added this component. Yeah, so if you know that you have a depth enabled device and your device is capable of getting or analyzing the depth, then you can use this very component given by ARFoundation, that is AR Occlusion Manager. Again, I was telling you about occlusion, so that is what they have named the component, right? So this has given you a few tools to estimate the environment depth with the best or the medium or the fastest thing. And it also has human segmentation. What this means is that this feature is again available in AR kit, if I'm not wrong, and that is why I was not able to check it on my Android as well. So what happens in this is that if there is a human in front of your 3D object in your AR frame, right, then your AR object will be occluded via the human in front of it, right? So that is more or less about this simple occlusion example. Let's take a look again, moving on. We've taken a look at image tracking. Okay, now we can take a look at light estimation as well. Yeah, this is one of the good ones, right? So let's take a look at Hdr light estimation. So here what we have is we have an arrow, okay, and this arrow basically points in the direction where the light is going. Okay, for example, if my phone is here and the light is coming from this angle, the arrow will be pointing here because the light rays are coming like this. Okay, so here we have, if we go, we have light estimation canvas, we have this rotator, this is none of our business, and light direction. So yes, on light we have this HDR light estimation. Okay, so and this is just the UI thingy that they are doing. Okay, so let's open this script up and let me just give you a brief example, because getting the light and doing the light estimation in ARFoundation is pretty easy. Okay, so what they're doing here is they're getting the, okay, this is not the HDR light estimation. Yeah, this is the very script. So here what they can do is there is a function named as there's a function named frame changed. So this function is automatically called whenever the frame is changed, and this automatically gives us AR camera frame event args. Okay, with the help of this we can ask about the light estimation, and within light estimation we have multiple things. If I control or command click on this, then we would have all the fields we can see. If we go for light estimation, so where is the light estimation? Yeah, so it is giving it, and let me go to the light estimation data. Yes, so this is all available in ARFoundation, and you can get the average brightness, average intensity in lumens, average, the main light brightness, maximum average brightness. You can set it, you can get the colors, right? You can get the intensity in lumens, in brightness, and you can get the main light color. You can even get the direction, which is really great. So what happens is, what ends up happening is, what we try to do to make things really work great and to make an AR experience realistic is, if you want the AR objects to feel real and part of our environment, we would want them to react to our light. For example, if this is an AR object and light is coming from this direction, right? So we would want the shadow of this object falling this side, right? Like on this plane, on behind it, because rays are coming from here, right? So, but the shadows are made by this light, right? This direction light that we have in the scene. So what we try to do is, first of all, we try to do the light estimation. Once we have the light estimation data, that is, we know what is the direction and stuff, we apply the direction of the light, to this very game object, which is our own light in the game, in the scene, right? If we have the light color of in the reality, like if in this color, in this reality we have a pink light, then what we will do is we'll get that color and change the color of this light. So this, because this is a light that is affecting the shadows or the, the AR, the 3D AR objects that we are placing. Those are not real things. Those are 3D, AR objects. And this is the virtual light that is affecting those things. So we try to match all the properties of this light to the real light we have in our environment. And what this, ends up doing is the reflection or maybe the shadows of the 3D object, which is not real, actually align with the real objects beside it, because it seems like the same real light is falling on the real objects as well as this 3D object, because its shadow is in the same direction as that of the real objects, right? So this adds up a lot of immersion, right? Because this really makes the 3D objects feel like they are a part of the reality. Okay, and I did have I did give this a try on my Android, and yes, Android has light estimation features. So you would see here, I would just show you how this behaves. Okay, so currently we can see, if we can see that this all area is bright and that shadow is being casted here, which means light is coming from this angle, right? And this arrow is also saying that the direction of light is this. And now I would just show you the direction where the light is placed. So see, the light is placed there and our phone was down, so the arrow is showing that the exact direction of light. Now what I will do is I will directly place my phone below the source of light. Okay, I'll just go, and you would see the place, this arrow will change its direction and will actually point even straight more towards, downward direction. So as of now, it's, see, it changes the direction towards down as soon as I come just below the just below the light source in reality. Okay, now I've raised my phone, I've just placed my phone just, maybe besides or just besides the light source. So now my arrow is pointing towards, where the rays are going, right? And although this might not be visible here, as soon as I place the phone downwards, you would see the arrow had actually changed its direction. See, it is pointing that way, right? Away from the light source as soon as I increase the height of my phone, because earlier my phone was here, okay, and light source was here. So the direction of the arrow was like totally downwards. Now what I did was I placed my phone here, okay, just besides the light maybe. So now light is coming like this. So arrow was also tilted like this, and it is tilted like this. And now when I'm bringing my phone down, the arrow will again tilt downwards. You would see here. See, the arrow is tilting down. So this means that we are able to estimate the light's direction and position. And you would see as soon as I block the camera is not getting any light, the main light color is gone, it says 000, and and you would see that the color of this island also has, it has dulled down, that is, it is now dull in color, right? As soon as I will remove my hand, it will again be bright. See, it changes, right? It takes a second to change, but yes, it changes. So this is the benefit of light estimation, and this is what really helps us to create realistic looking light effects. For, see, now I have closed the light, and you can see that the color has dulled out, like it looks dull, right? Now I have switched on the light, it again, becomes bright. How amazing is that, right? That you can actually affect the virtual objects lighting and, its brightness, virtual objects brightness and stuff with the help of the real light. So that was pretty amazing for me, right? So that is an example of light estimation. Okay, so these were a few things that I really wanted to showcase you. There is another thing that we can see, and that is, let me just find it out. Yeah, I wanted to showcase you another thing, that was this interaction demo. This is also a pretty interesting scene that they have given. So here again, you would see we don't have much things. We have AR session origin, and here we do have plane manager, we do have point cloud manager, and we do have AR recast manager itself. Okay. Then on the AR session itself, what do we have here is we have this AR placement interactable. So this is a component which is responsible for placing of stuff, right? And with the help of this, we can place stuff. These are interactable events. We can, whenever the object is placed, whenever we have first hovered over it and we are hovering over it, selecting it and whatnot, right? And then we have this XR interaction manager itself, which is used. So basically what this has is, this has a manipulator cube. And this is what is important to check out, right? Because on this manipulation cube, we have 3 to 4 very important components. First and the foremost is the selectable component. So this helps us to make this cube selectable. Then we have a AR translation interactable. This helps us to make the cube translatable. But that means we can actually, the user can raycast over it and actually drag it to move anywhere. Then what we have is we have a AR scale interactable. Here again, as the name suggests, it helps us to scale the cube, and we have multiple options also here that these are known as properties. And this we can set the minimum scale, the maximum scale, the elastic ratio limit, sensitivity, and elasticity, right? And then we have the rotation interactable. This again, as the name suggests, will help us to rotate this very cube. And again, we can set here the some of the arguments, not the arguments, the properties, right? So let's see this very demo in action. And I believe I have the recordings as well. So let me go to desktop demos, and this is the one that we're talking about. So here, if you see, what is being done is that, first of all, I'm simply scanning the plane. We have a plane manager. That is why the things have been scanned. Now, with the help of placement manager, we are able to place these cubes. But then with the help of the selection component, we can actually tap on these very cubes, individual cubes, and select them. As soon as these are selected, you would see another transparent boundary just outside of them. And then I can actually keep clicking on it and drag it, move it, right? Drag on my screen to move it. Then again, I first have to select something, and then I can drag to move it, right? So this is being done by the AR translation interactable, right? Now next comes the scaling component. So we have a AR scale interactable, with the help of which we can scale it. And you would also experience, or you can also actually see here, that we cannot scale out or scale in beyond a certain extent. As you can see, I'm trying to scale here, but I cannot scale it more, right? Because we have set the properties of the AR scalable interactable. Then this is the AR rotation interactable. We are rotating this. We are able to rotate this very cube with our gestures and stuff, just by using that very simple AR rotation interactable. So these are a few components that are very useful, and these can be really handy if and when you want to create a interactive AR experience, right? Where you want the user to place the things, but also then being able to move the things, rotate the things, or scale the things. Because with these three functionalities, the user can place the object wherever he or she wants to. Earlier, as a matter of fact, before ARFoundation or stuff, this was done by a plugin known as Lean Touch. So that also gave us a few components which we can simply put it on the object itself that we want to move or drag or scale. And those were lean touch transable, lean touch rotation, and lean touch scale level. And with the help of these, we could also rotate, move, and scale the object. But it's great to see that ARFoundation has already taken care of them, and now we don't need a third-party plugin. So these were a few scenes, a few important scenes, I must rather say, that I really wanted to showcase you and just show you how these works and what are the major components. I would highly suggest you to go through them, these scenes in depth, and actually try to build them and run them as well. Because while doing so, you'll be learning a lot more new things. Because we didn't, take a deeper look into these, because we wanted to show you multiple scenes in this video, right? And now also we know that you're good enough to go explore yourselves. So that is also a reason that we are not going through all the scenes, because till now, in the last 2 to 3 days, We have explained you how to learn on your own, how to explore a scene. We have been exploring simple AR scene, and then we created a replica of that as well on our own from ground zero, right? So that is what I would recommend you to do with these scenes as well, and try a bunch of more scenes as well, right? So this was it that I really wanted to cover. These were all the important scenes that I wanted to cover. And as this is a last year foundation video, I would suggest that let's do a recap. Let's do a recap what we have done in air foundation. Okay, quickly let's do a recap. So in air foundation, we have taken a look at a package from Unity itself named air foundation, which helps us to build, write single code and build, two and output two APKs, or two application packages. That is, one might be APK and one might be an IPA, that is for the iOS devices. So with the same code we can build for Android as well as iOS, right? So this is the very main reason why Air Foundation is so famous and why it is in so much demand. And if you are a AR developer, you need to have the skill to develop with Air Foundation, right? So this is what Air Foundation does, and this is a package not provided by Apple, not provided by Google itself. It is provided by Unity, and Unity keeps a great job at updating this as soon as ARKit or ARCode update its list of features, right? So that is why we are so much into Air Foundation, and we gave it so much time. And Air Foundation also is responsible for giving us components which are pretty easy to use in itself, right? Because it could be cumbersome to use features from AR Core and ARKit because they have their own documentation, their own way of doing things. But with AR Foundation, everything is streamlined. And now, as a developer, I am happy because I just need to code once and I can deploy in multiple platforms, right? So that is why Air Foundation is really important.